any level based on your interest and aptitude. You can join the program during the January admission cycle or the July admission cycle. So what are you waiting for? You go to IGNOU Samarth admission portal and register yourself.
Hello learners, welcome to this session. This particular session is a very important session with respect to the text mining. In this particular session we will discuss data mining, block 4, unit 12. So in the previous sessions we have discussed about the introduction to text mining, and then in the next session we had discussed about the text pre-processing, which was also an important stage. So in this session, let us discuss how to convert the text into the feature vectors. Or else what exactly is the text transformation or else text vectorization that we are going to discuss today, and what is the significance of changing the whole text into a kind of vector, why it is necessary. So these particular things we will discuss it in today's session. So text data, as you see, it is represented in the form of words, sentences, paragraphs, or else the whole document or flowing of the complete text as a raw document. And this particular text or else the document may be very much unstructured in nature and contains noise, and this may be creating a kind of difficulty to the machine learning models whenever they work directly onto the raw data. So there are several applications which the text data has, like for example, text classification is one example, sentiment analysis is another example, opinion mining is another example, information retrieval is another application. So in order to do these kinds of applications directly working on the text by the machine learning models is a difficult task. So what to do? There is a process called as feature transformation. So this particular process is nothing but it converts the raw data, which can be of text, image, graph, whatever the case may be, into a numerical vector, or else you can say it as a numerical feature. So here computers normally understand wherein which it needs to be converted to the understandable format, that is the zeros, unknowns, or else the numerical values. So this feature transformation is also called as the text vectorization also. So these computers are great in understanding the numbers. In order to help the machines to understand, manipulate and produce the words, we have to convert these words to numbers. That is the understandable format by the computers. And this process is called as feature transformation, or else you can call them as the text vectorization. So this is nothing but it turns the words or else even the complete document into a mathematical representations. We call them as the vector translation. So these representations capture the semantic meaning in a multi-dimensional space, and this particular step is very much important for all the natural language processing applications. So let us see the significance, why it is required. So textual data normally comprises of words, and then some sentences, paragraphs, documents, which are inherently qualitative and unstructured in nature. So these vectorization algorithms transform the whole text documents into the numerical vectors by encoding various linguistic features such as word frequency, word context, and or else the relationship between the words within the text. So these particular vectorization algorithms works by transforming the whole text into the kind of understandable format by the computers. So one particular significance here we can discuss is the feature representation. So numerical vectors derived serve as input features for machine learning models, as we know. So this allows the algorithms to process and analyze textual data to perform text like the text classification and the sentiment analysis. And the second significance that we can discuss is the semantic understanding. So this particular text feature transformation captures the semantic relationships between the words, one word with the other word, what kind of semantic relationship it possesses, allowing the algorithms to understand the meaning and the context of the text. So in many languages, the whole word also depends upon the context in which we are using. So sometimes we may be using in a different context and sometimes it may be used in a different context. So semantic relationships is also very much useful in nature. So these semantic relationships remove the need of depend upon pure syntactic differences to understand the whole text as such. And the third significance we can discuss is that data integration. So the data can be in structured format, unstructured format, or else in the semi-structured format. So most of the textual documents are in the unstructured format. So these vector representations of text can be integrated with structured data for comprehensive analysis. So already the structured data is available and we have to change this particular text is also into the vectorization of the text, and then it can be integrated and we can do the comprehensive analysis of the structured data, enabling organizations to derive insights from both textual and the non-textual data. So here we can combine, we can integrate both the structured as well as the unstructured data that is present in the document format, which needs some sort of vectorized translation, and then later on we can club up with the structured data and we can do the comprehensive analysis of the document. Let us see what are the techniques those are available in order to do the vectorization of the text. So the common techniques that those are available is, one is the bag of words, which is very much popular and is called as BOW. And the second one is TF-IDF, that is term frequency, inverse document frequency. This is the second technique which is commonly used for text vectorization. The third one, which is the latest technique that is used in many of the machine learning models, is the transformer models like BERT and others. And there are some deep learning methods which are called as word-to-vec, GLOVE, fast text. So these are some of the deep learning models which are wherein which most of the people, whenever they go for whenever they use the deep learning models in order to do the natural language processing, they use the word-to-vec, fast text, or else the GLOVE kind of methods. One by one, bag of words model is very much simple and straightforward approach to vectorized text data. So it represents documents as vectors where each dimension corresponds to a unique word in the vocabulary, and the value represents the frequency of that word in the document. So here you can say the presence of the word may be taken as 1, non-presence can be, or else the absence can be treated as the 0. So here this particular model is very much simple, and this is used for document classification. That is one application that bag of words has. Second is the sentiment analysis. Most of the sentiment analysis are Twitter analysis. Those are being done using this bag of words, vector textualization. And then the third application here we can discuss is the information retrieval. So all these three applications uses this particular technique called as the bag of words text that is vectorization of text technique. However, it ignores the order and context of words. Here, this is the drawback that the bag of words has. It doesn't concentrate upon the order in which the words are arriving. That is one particular disadvantage, and the context of the words. So that is a second disadvantage that the bag of words is having, which can limit its effectiveness in capturing the semantic word. Here we can say that bag of words is the very simplest kind of technique and popular technique which has arrived in the earlier stages of NLP. And let us see one particular example to understand the bag of words. Says this movie is spooky and good. So whenever we use the bag of words kind of technique, we have to list all the unique words. So among the three documents that those are available, we have to identify all the unique words. Here you can see this is also appearing in all the 3 documents. So here we have to take only one instance of the word, and then rest of the repeated kind of thing we can avoid. So here you can see we are ending up with the vocabulary. You can say that particular unique words clubbing together is called as a kind of vocabulary. Here we can use that particular term, and then we are ending up with 11 words. THIS, this movie is. So all these terms we had picked up, and then these particular words are, or else we can call, we know the said vocabulary has 11 words. We can use a fixed length of 11 in order to represent each document with one position in the vector to score each of the words. So here we have to prepare a kind of simple table consisting of all the 11 words, or else you can call them as 11 terms. The simplest scoring method here we will use is the 0 for the absence and 1 for the presence of that particular word. For example, if you take the first document, the movie is very scary and long. Here you can see this movie is very scary and long. So all the 7 words, or else you can call them as the terms, will have the presence of 1. And then later on the other 4, that is 7 plus 4. The other 4 we don't have that particular presence of those particular words in the first document. So we put zeros in the vector. So here you can see I had represented all the three documents over here. This movie is very scary and long, and we had converted that particular document into the vector space. So here you can see the 7 representation, 7 ones represents the whole presence of the words, those are there, and then later on the same thing is happening over here. So whichever the word among the vocabulary is present, we will put 1, and the rest of the things we put the 0. So here this is how we convert the whole document into the kind of vector textualization. So some additional simple scoring methods includes, you can have the counts, that is the count of number of times each word appears in a document. That also you can do. The frequencies, the how many times the same word is being repeated, that also you can count using the frequencies. So these are some of the additional simple scoring methods that we can have from the bag of words. So as we told in the earlier slide, the drawbacks is nothing but whenever the document size increases, if at all a new sentence contains new words, then the vocabulary side, or else the list of the unique words will also increase. Thereby the length of the vectors would also increase accordingly. And the second drawback may be additionally the vectors would also contain many zeros, thereby resulting in a sparse matrix. And then the third drawback is we are retaining no information on the grammar. We are only just checking whether the word is present in the document or not. That is the only thing that we are capturing in order to form it as a vector in the survival. We are not at all recording the order also. Here just we are seeing whether the word is present or not. So that is called as the TF-IDF. So term frequency, inverse document frequency tries to overcome the limitation that we had discussed in the previous slide using a kind of technique called as scaling or normalizing in its computation. So it uses 2 types of metrics. One is the TF metric, that is the term frequency, how many times the term is occurring in the document. And then there is another metric called as inverse document frequency. So both the terms we will calculate, and then we will see how many times the term frequency is there, or else how many times the inverse document frequency is appeared. So here the formula goes like this. Term frequency, it is a measure of how frequently a term T appears in a document D. So that is the term frequency, and it can be denoted in the formula that is shown on the slide. That is T is equal to N by number of terms in the document. And then there is another formula for the inverse document frequency. That is, it is a measure of how important is the term. And then we need the IDF value, because computing just the TF alone is not sufficient to understand the importance of the words. Here we are also seeing the measure of how important a term is, how many times it is repeating, and how important that particular word is. That particular frequency is also we are trying to calculate. And the formula goes in such a way that ID is equal to log of number of documents divided by number of documents with the term T. So that is the formula for the Let us see the whole thing with the kind of illustration here. So how to compute the IDF for one particular document? This movie is not scary and is slow. So that particular document I am taking it as an example. Here you can calculate the word length. The terms are 8 in size, and then TF for one particular word we will take, that is one particular term we will take, that is THIS, and then number of times it is in this particular document it is appearing only 1 out of 8 terms in that particular document. So 1 by 8 number of documents containing the word this. So already we had number of documents altogether, we have 3 in the previous example that we are taking, divided by 3 number of documents containing the word this. So number of documents is equal to 3, and 3 times THIS is appearing. So log 3 of IDF. So TF with the IDF is 1 by 8 into the 0 is equal to 0. So this is how we calculate the TF and the IDF. So here you can see we are this particular illustration shows the complete 3 documents. Here the vocabulary is once again 11, length of 11, all the terms I had represented over there, and then for each and every document I am calculating, each and every term I am calculating the TF, and each and every word I am calculating the IDF, and then we are calculating the TF and the IDF. You can see this the TF into IDF is 0. Movie it is also appearing 0. Likewise we had calculated the TF into the IDF, and the scores you can see scary is having 0.022, and then not is having 0.06, and then slow is having 0.06. Otherwise the other things are coming into the sparse matrix. So IDF assigns higher weights to the terms that are frequent in a document but rare in the corpus, thus emphasizing terms that are more discriminative. So this particular technique is widely used in information retrieval, keyword extraction, and document clustering. So these are the applications of the TF-DIF. Otherwise we had seen for the BOF it is textual classification, information retrieval. So those were the applications of the bag of words. All sentiment analysis was the example of bag of words. And this particular technique work has appeared very recently, that is called as the transformers technique. So this transformers technique is a type of neural network architecture that have become a cornerstone in the natural language processing. So unlike other models, this particular model processes the text sequentially, one word at a time. Transformers process entire sequences of text simultaneously. So this doesn't mean that it goes by one word to another word. However, all the text simultaneously will be processed by the transformers. So this is a very efficient technique, and then this results in employing positional encodings to encode the order of words or tokens. So we had discussed the drawback in one of the technique called as bag of words, wherein which it doesn't take care of the order of arrival of the words. But here the transformers is taking care of that particular limitations, and then it will be working on a kind of principle called as positional encoding to encode the order of words tokens in a sentence rather than feeding the same sentence in the order into the network. So sequentiality is encoded in the input rather than through the architectural design of the model. So there is another technique. So this technique is used to represent complex high dimensional data like words, sentences, or even entire documents. So this is not just like a old method called as one-hot encoding, wherein which every word is a separate binary factor, which means it is also having a kind of basic representation. But older methods like bag of words and TF-IDF, the drawback is that they don't have the semantic relationships, or else they are not maintaining the kind of arrival of the order of words. So here in the latest deep learning techniques like the word embedding techniques, this has been taken care. The first word embedding technique that we can discuss is the word to vec, which is very much popular, and this particular word to vec is being developed by Google. This model uses simplest neural networks. It is completely based on idea that words in similar ways have similar meanings. That is the basic idea that they had taken care while developing the word to vec. So it has two types. The first type of word to vec is that it looks at words together. the combination kind of thing is being looked in the first principle or else the first type. And the second category is that predicts surrounding words also. So these are the basic things or else the basic types or categories of the word-to-vec embedding. So this particular word-to-vec is an algorithm that accepts the text corpus as an input and outputs a vector representation for each word as shown in the diagram below. You can see there are several kinds of documents, those are there given as the inputs to the neural network. And then there is a process called as word-to-vec over here. And then the output, you can see there the kind of vector that is being, vector representation that is formed for each and every document. So this is how the word-to-vec works, that too using the two types of principles. One is that looks the words together, and the second one is it predicts the surrounding words also into consideration. So two types of word-to-vec is there. There are two flavors for the same algorithm. One is common bag of words, and the second one is skipgram. So given a set of sentences, the model loops on the words of each sentence and either tries to use the current word W in order to predict its neighbors. So it is using the second principle, which is called as the neighboring principle, and this approach is called as the skimgram. Suppose if it uses the first kind of thing, it uses each of these contexts to predict the current word. In that case, the method is called as the continuous bag of words. So CBOW is the second category, second type of the word-to-vec. To limit the number of words in each context, a parameter called as the window size is also used. So this is how the word embedding will work. And then there is second method called as GLOV, which is once again a kind of deep learning method. And the full form for the GLOV is Global Vectors for Word Representation. And this mixes the two approaches to learn the word embeddings. It uses the co-occurrence. Here one thing it likes to do is the co-occurrence. Whenever one particular word is occurring, then it sees for the second word immediately which occurs along with that particular word. So to understand the word meanings on a broader scale. So this will be helping the kind of technique. Co-occurrence is the kind of technique that is being used by the GLOW. And then there is a third technique called as the fast text. So this particular fast text is created by Facebook, and the earlier thing was created by GLOW was created by Google, and then this fast text is created by word-to-vec was created by Google, and then this fast text is created by Facebook, and then this breaks down the complete sentence or else the document into smaller pieces like the character groups, and then this helps it understand different word forms and rare words, which is especially helpful for languages that changes the words. So these are the three techniques which are very much popular when it comes to the deep learning methods. And currently, whenever the machine learning or that using this particular deep learning for the NLP applications, these three are the things that are used by the researchers or else the application developers. One is the word-to-vec, and second is the GLOW, and third is the fast text. So before winding up, let us recap what we had studied today. We had completely seen what is the significance of doing the transforming text or else the text vectorization that we had seen, and then what is the significance of these particular things, like where it helps. One particular significance we had seen it as the feature representation, second is the semantic understanding, third is the data integration. So all these things are the three significances primarily for the text vectorization that we had seen. And what are the techniques that actually are used for text vectorization? One we had seen as the bag of words, which is very much simple in nature and is very popular technique. And second is TF-IDF. And then the third one is the transformers, which is a machine learning model, which is very much popular nowadays. And then the third thing that we had learned is the deep learning techniques called as word-to-vec, GLOW, and then the fast text. Hope you had understood these particular techniques, and if you want more information about these particular techniques, please read Unit 12 of MCS 221, Data Warehousing and Data Mining. With this, I conclude the session. Thank you.